Good morning, everybody. I see we've got Fort Lauderdale, Philadelphia. We've got quite a great group here. Balboa, Lake Balboa, Athens, Greece. Welcome, welcome. My name's Kristen Petrovich, and I have the privilege of working with the Society of Camera Operators. Happy Sunday to all of you. Thank you so much for joining us. We will have time for questions at the end of the session, so just to let you know. And if you have questions, please chat them in as we go along, and we will curate them at the end of the session. And if you need anything, any technical issues or questions, please go ahead and chat them in. We'll be overseeing that throughout the session. And thank you so much again for joining us. I have the pleasure of introducing Mitch Dubin, and Mitch Dubin is the first vice president, and he is also the committee chair for the educational committee. So good morning, Mitch.
Morning, everyone. Thank you all for showing up bright and early, although we have a truly international presentation today. So it's morning for me, but it's night for the gentlemen of Mo-Sys who are in London. Really, it's a truly international presentation from California, Atlanta, and London. The first thing I want to say is that to welcome Mo-Sys, who is one of our newest corporate sponsors. I want to thank you so much for your support of the SOC, and I look forward to us very excited about working together with you. I also want to say a little bit. I mean, what we're talking about today is the Mo-Sys Remote Head, and everyone now is starting to get back to work a little bit, but we're still in a COVID environment. I personally just finished a project working in a COVID set, and I have to say, and I'm sure it will be stressed by the people at Mo-Sys, but that having a remote head on set is really critically important for the safety of everyone involved, the actors and the crew. So having equipment available like what Mo-Sys has it's wonderful for all of us in the camera crew. And also, before I introduce everyone that's going to be presenting today, I do want to say that as the chairman of the Education Committee, what we're doing today is sort of a novel approach that the Mo-Sys is doing the presentation, and it's a hybrid hands-on virtual presentation. But expect to see a lot more of these. We're going to be very active in the Education Committee of the SOC, and this discovery of this hybrid virtual hands-on type of workshop, I think is going to be very valuable to our members. So expect to see a lot more. I don't want to take up too much more time, and I want to introduce the people that are going to be presenting today. So from London, we have Michael Geissler, who is the CEO of Mo-Sys. You want to raise your hand and just say something?
Hi, Mitch.
We also have Marcus Wootke, I hope I pronounced that correctly, who's staying behind the scenes, but he's also from Mo-Sys. And then we have Kenneth Mckenzie, who's a key grip in Canada, I believe, who has prepared a video that we're going to be watching. And then we have Gary Tanasio, there he is, just business development of Mo-Sys. Joe Allegro, who's general manager of ProCam Rentals in Atlanta. And there he is, Bob Gorlick as well. So Michael, I'm going to let you take it away from here. Thank you very much.
Thank you very much, Mitch, and thank you very much, Christine, for that opportunity. And we're really, really proud to be part of this and to be able to, yes, talk about the L40, but actually want to take the opportunity as well to try to do this more educational rather than salesy. And I thought, why not actually, we have a lot of experience now with remote heads, and we're doing this for a lot of years. So why not a little bit opening up and sort of show what is from a manufacturing point of view behind the decision-making process of designing a remote head, and how does that influence the filmmaking? And I'm sort of trying to open up there and making it more educational rather than salesy. Yes, we have a little slideshow. First, it will tell a little bit about who we are. Yeah, we're at the location in Atlanta at Procam, and we're really proud to thank you very much, Procam, to giving that opportunity. And yeah, thank you very much again for the Society of Camera Operators. Now, Marcus, next slide. Thank you. So what Mo-Sys is doing, we started off with doing remote heads. And at the very beginning, actually, was motion control system, then went into remote heads. And then in order to move remote heads with a pan bar, we needed to figure out encoding pan and tilt heads. And that also led us then into camera tracking, and then later into virtual production. And now all of this is coming together, sort of camera tracking, the remote side of things, and the virtual production, particularly with the sort of strengthening Unreal Engine. And it's sort of one complete portfolio now. And at the beginning, everybody's saying, whoa, that goes all sort of different ways. But now it's coming together. So our heads are used on a lot of big films. There's Life of Pi, and there's Gravity. Gravity was fun because normally it is our customers who are then using the heads on films, and sometimes we don't even know where. But Gravity, they actually came directly to us, and we were involved in the problem solving, and that's the bit we sort of, as Mo-Sys, enjoy. The idea was to create a head that lets light through, but yet is super strong and is withholding all the accelerations that you have on those sort of at the end of a robotic arm, and the shape of water, the L40, for example. But I think there were many more. It started off for Mo-Sys with motion control system. That was always my dream, to make something super accurate, and then repeating moves, and we did this and brought that into the market. But then it was actually Nico Balle from Cranium who came like, whoa, that thing is super precise. I just want the head, and it just is so precise. This is what we need. And that's where it started, actually, that we orientated towards the remote heads, and that was actually quite a journey. And I think, I don't know, 15, 20 years ago. Pictures on Gravity. Gravity was a highlight, as I said, because they sort of involved us. Now, I want to dive into the most important component of a remote head is the drive and also the frame. So these two are sort of key criteria that sort of shape what you can do with it or what it's useful for. Now, on drives, there is, for example, a worm drive. A worm drive is a very, very simple drive. The nice thing is they are cost efficient, or they can be cheaply produced. The problem with worm drives is that they either seize or they don't have, or they have gaps between the teeth. So it's very, very difficult to line them so up that they are just not having play, but not yet seizing up. And the other problem is that the moment you have temperature changes, very often the housing is out of aluminium and the gears out of steel or brass, which has aluminium has twice the temperature expansion as steel. So you actually theoretically, if you have a big temperature change, you would need to start to adjust them to get them really right. So that's why they always have a little bit of play, and that ends up in, if you have a sort of slightly one-sided load or a large load, you can sort of end up in juddering. And that's why there are other gears that are slightly more advanced than worm gears. So there's, for example, a direct drive. A direct drive is just a motor. There is no gear. And you can design motors in a way that they have more torque and they don't spin that fast. But actually a gear gives a motor a lot of force. So in order to have a direct drive motor that is as strong as a motor with gear, it has to be, I don't know, 10 times heavier and larger. So normally you end up with a direct drive that sort of has less compared to the same sort of weight ratio. But a direct drive gives you advantages. You can, it's ideal for stabilization, for example. If you would switch it off in a direct drive, there is no resistance. There's no gear that gives resistance, and that is quite nice. So you want to use that for stabilization. It's actually ideal, but you may end up with either something heavy or something not very strong. Another drive is a cycloidal drive. This is like a sort of hula hoop that moves in. It's quite a funny principle, actually. But they have the advantage that they are super strong and have no backlash. You do have a little bit more noise that you have to sort of fight with. And it looks like none of those, and that's what we, for example, have in the L40. And it allows the L40 to have the largest lenses you can imagine, or cameras, and it doesn't matter. It just like will be precise. If it's a heavy load, if it's a one-sided load, it doesn't matter. It always is precise. It never has any backlash and play in the gears, and it's precise and reliable. Having had all this experience over the years, we then actually thought there needs to be something for the film, but also for the broadcast industry, that allows us to have all of these benefits together, because there isn't the sort of ideal gear. And we invented the jam drive. It's patented now, and the jam drive is something that has zero backlash, so it gives you the precision. It's super quiet, and it has a massive through hole in the middle. So, for example, that's one of the problems of those cycloidal gears that the L40 has, was the hole in the middle. And in order to make a large hole, we designed our own motors, and those motors, I think they're 4 times stronger than, for example, the Lambda that we had before, just to achieve the hole in the middle. But the jam drive has naturally a large hole in the middle, and we designed that primarily for broadcast use, because there's much more budget conscious, yeah. Then I want to go to the frames. You have an L-shaped frame, so it's like a one-sided. It has the advantage that you can get to it easily, which in the film industry is quite important, because you want to put all the motors and monitors and whatever you want onto that, and it gives good access. The next one would be a U-shaped head. We actually, that was a funny one. It is actually an L40, the whole gears and drives, and we changed that just a few months ago during COVID, because suddenly somebody said they would like to see some really, really strong remote heads for box lenses and TV. I mean, they're heavy. I mean, they can be like 20, 25 kilo each lens, and they want something super precise. And we said, well, easy. We have super precise and very, very strong heads. So we loaded an L40 on that, and box lens on an L40, and swung that around and said, whoa, it all works fine, doesn't it? Until we got the feedback, like really to zoom in with those heads and with those cameras, those lenses. And I think it was 1,600 millimeters at the end. And they asked us to do like a whip pan. And apparently this is what you do if you sort of follow ice hockey pucks and stuff like that. And there was actually quite some twist in that L40. And that's why we then created the one on both sides. It has less accessibility, and it's more a monster, and it's quite heavy. I mean, there's one right behind me here. So you lose that compactness, but you have a head that allows you to, even with 1,600 millimeters, to do whip pans and nothing wobbles. Next thing is the number of axes. Now, You have 3-axis heads, you have 2-axis heads. Film industry often is used to 2-axis heads. And you can, for example, on the L40 also add an additional roll axis. And we specifically kept it as a separate module that on set you can add to it, because it is a more rare occasion that you actually do require a roll. And we thought the flexibility and the compactness and being able to carry it around is a bigger benefit than the rarer occasions where you have a roll axis. That's why we kept it modular. But you do have other heads that actually, or here, it is, yes, it's the this one is the lambda now with the added roll axis into it already. But it makes the head more complex, heavier, larger. And if you don't use the 3rd axis that often, then that made it a better choice. Here's a video of actually, of sort of those rare, more rare occasions why you use a roll. Just like a Dutch angle. Okay, that's extreme, it's 90 degrees. Okay, then we have 4 axis, but that actually got mangled up. We should discuss that with the stabilization. And I think we should then jump back to that. No, you have on the stabilization 3-axis heads and a 4th axis. For example, here the matrix head gets added to avoid what is called the gimbal lock. Okay, we get to the slip rings later. No, here are the slip rings, and we get to the number of axes later. Cable management. Slip rings. You can have slip rings. That means the axis can turn actually forever, and you have special adapter cable that allow you to connect through that, and the slip rings turn internally, and you can turn it forever. It's quite nice, but disadvantages is it's probably the most vulnerable part on a head. And if you're constantly on a day-to-day basis leg this head around and constantly plug in and out cables, then it is the weakest point in the chain, and the second weakest is the connectors themselves. And here on the right-hand side, you actually, yes, sorry, that's the slip rings as well. So you end up with lots and lots of connectors that sort of feed through. On the L40, we catered for a hole in the middle, and that allows you to put the cable through, and you don't need slip rings. But you can probably do 2 or 3 revolutions left and 2 or 3 revolutions to the right. So you end up with like 6 to 6 revolutions altogether, which I think you probably rarely need. But it allows you to just feed cable through. On the L40, the hole is, I would have liked to see it bigger, but for that already, as I said before, we actually designed our own motor. We manufacture our own motors. We glue the magnets into the motors. We built that all ourselves, but it was very difficult with that cycloidal gear to actually achieve a larger hole in the middle. As I said before, this motor is about 4 times stronger than the Lambda, Mo-Sys Lambda was in the first place. Not to make it stronger, but just to achieve that large hole in the middle. Other cable management option is the fiber option, and with that, then you can go up to 20 kilometers, and it's often used in sports events where you have sort of long distances to cover. We have the radio. That's another option. I got actually one here, and a radio helps to bridge distances, and especially during Corona, we're seeing a high demand in those radios now suddenly, because a lot of people end up moving the head around on set and creating freedom, and the operator actually being somewhere else behind the monitors, but not clogging the scene around the camera and creating more space around the camera. Okay, now in control systems, you have analog control systems. They are rarely now. I think in the broadcast industry there's some more. I mean, like the sort of Jimmy Jib or something. So these are analog heads. There is no digital control, which means in the old days when you moved something with hand wheels, you could end up that your head is moving, but your hand wheel position changes over time because you just lose some steps. Or when it goes really, really, really super slow, then an analog system would have difficulties to sort of catch up, and it may lose some motion. Then we have the digital system. Now there is something that's called a centralized system. You have a central computer, and then to every device, to the remote head, to the crane, to the lens. If it's a complete robotic system, you want from that central computer to each device having a cable going. But then I think 20 years ago, we actually started to design our decentralized system. And the idea was that to simplify it. And that means we daisy chain. So there's not one central computer or brain, that each device has its own processor. So this part of the radio has its own processor, the console has its own processor. And all these devices, we daisy chain them together. So it's not a star configuration, but they daisy chain from one to another, and then from here to another module. And it doesn't matter in which order you plug things in. It will always work as long as you plug everything in. And these connectors, you have the same two connectors on each one of our products. And there's one that you can choose any one of these to go in and the other one to go out. So, and the cable, we have a special custom designed cable that transports the power as well as the signal. And the idea was to make it really, really simple. And you don't need to think and consider which cable goes. You just plug everything in at the end. And we call this whole thing then daisy chain a bus. And at the end of the bus, okay, that's the only thing one has to remember, and very often it gets forgotten, is what we call a terminator. And that has to go into either end of that chain. It's nothing else than a glorified 120 ohm resistor, if you should ever lose these. But then plug them into the wrong pins, because otherwise the whole thing blows up. So better have some spare ones of these. Okay. At one point, that was pretty unique for Mo-Sys to have a decentralized system and daisy chain from one device to another. So then I want to talk about payload, because there's a lot of confusion, and heads now get measured with how much they can carry. And I mean, we also use it. We call the L40, and this behind me is the U50, and we have a L20 as well. But it's actually not that scientific, the payload. And it's definitely not about, if I add some more kilos, the frame breaks off. I mean, on the L40, for example, you can hang a thing up to 120 kilos. And the frame is still, but it's actually more about the acceleration. And if you see on that picture, it's quite a large camera package. And our heads just swing that around. So even if it's a small package or a large package, there is no difference. And if you go for the Lambda up to 50 kilos, you can swing that camera around without suddenly it needing to slow down or the system not coping with it. So the measure of the payload is actually more of what can you accelerate without making compromises. And if you go beyond that payload, you will start that maybe you should sort of move a little bit slower or accelerate slower. So don't be confused if somebody says like, okay, this head is for this payload or for that. It's not about the weight, it is about the acceleration. But I see some manufacturers actually having then super small motors and still saying it is for, I don't know, a ridiculous amount of kilos of heads. At least for Mo-Sys, we see that basically there should be no compromises up to that payload in your acceleration. Another part is the bearings. They are, especially when you are on a telescopic crane and you move fast out and you stop, you can get into sort of judder. And at one point you start needing, so the faster you want to do that, you need to have a gyro-stabilized head just to basically stop that load. But if your bearings have play, then you end up with this. So you move out and you earlier end up with judder. And what we tried with the L40 and as well the Landers, they have a special cross roller bearings that are actually having no play and there is no give at all. So with an L40, you can actually end up using it for quite a long while on a telescopic crane without actually requiring a gyro-stabilized head. And that's why we're so especially focused on the bearings. Okay, now it goes to stabilization. Stabilization is a little bit of black art. You can't read it up anywhere, how to do it and what to do. What I want to show with this video is what I call active stabilization. And there are also no proper names for the different categories, and every manufacturer sort of is inventing his own naming convention. I call that, for me, there are two different ways, and one I call active and the other one is passive. While watching, maybe let me try to explain that. I have a heavy sort of brass rod here, and similar to this Leopard tank, that is active stabilization. So if I need to compensate here, I need to measure, and then I need to weigh. It's quite heavy. This is solid brass. And if you would sort of, if I would go up and down, I need to sort of measure me going up and down, and then very quickly adjust the motors, and the motors must be bloody strong because they're actually holding just that to one side. So for me, this is an active system, and that is all about the speed of measuring until the motion sort of detecting the motion and then ending up doing that compensation motion. So the time difference is extremely critical, and the systems are extremely strong as well. The other one I would call like a passive system. So you have a fully balanced system, and even if you wobble it around, the thing actually wants to stay balanced, and which means the motors you're starting to use, you would like to have as little friction as possible. So direct drive is the best, and then the motor is just basically to notch the direction of and change slightly the direction rather than actually holding it. I hope that sort of helps. Then there are also combinations of those two. Jumping back to this active, of course, nobody would have that sort of one-sided system. You still would sort of balance it because it helps as well. Now, another way is to combine those two, and you have like an inner and outer stabilization, and you have the inner one that is sort of carefully balanced, and in this case, Westcam, I think they have a button on that. You have like a magnetic inner one, so the whole thing is to suspend it so none of the shocks or vibrations are sort of getting through the small ones, while the outer cage is sort of following it around. So you have a combination of those. It's quite complex, and I think for the film making, probably you end up with a super complex system that can stabilize lenses far beyond what is normally used, and yeah, but it's a much more complex system. One more thing to stabilization. We just discussed about the reaction time, and what you try to do is to have an ISO damper to basically slow things down, slow motion down, and you also have shock absorbers to slow motion down so that the stabilized head can easier cope with that. Yeah. Good. Now, the next thing is the order of axis. That's quite an interesting one. Most heads have like an most unstabilized, non-stabilized heads have a pan, tilt, roll arrangement, or just a pan and tilt. When you have pan and then the tilt axis and then the roll, you cannot end up with what is called a gimbal look. So if you then have the camera looking down and you have your roll ring, then suddenly, so I do that again. So you have your pan, you have the tilt, and then you have a roll ring on the tilt. And if you then look down, suddenly the roll axis has the same orientation as the pan axis. So you lost one axis. And that means with this order of axis, you cannot look left or right anymore when you look down. You can go this way, but you cannot go sideways anymore, which means you cannot stabilize when you look down, and you cannot move the head either in look down. And that is one of the big problems of that order of axis. Now you can get around it, let's say like the matrix head that adds one more axis, 4 axes, and then suddenly you have all degrees of freedom. You don't have a gimbal lock anymore, but you have one more axis. The other way to do that is you have a pan, roll, tilt order of axis. And that is very common in stabilized heads. And even if they have the same order of axis, these heads can look very, very different. So for example, what you see on the left, the flight head, it has the pan, then it has the roll axis at the back, and then afterwards the tilt. So now if the flight head is looking down, you can still go left and right, and you can forward and backwards, so basically pan and tilt with a head. The same thing as for our former G50 or the Libra head. If they look down, they are A, stabilized, and B, you can move them. You still have a pan action in your camera.
Here's 2 simple animations to explain what gimbal lock is. In some gyro-stabilized heads, the frame geometry and the priority of the axes combine to reduce the effectiveness of the stabilization when the camera points vertically down. In this design, when the camera is horizontal, the pan axis, the tilt axis, and the roll axis all operate as expected, providing 3 axes of stability. However, when the camera points vertically down, the pan axis operates as expected, as does the tilt axis, but the roll axis is now identical to the pan axis, and this effectively removes 1 axis of stabilization in this head design. Here's 4 other designs of gyro-stabilized heads, where the priority of the axis is different to the first design. In these designs, the axis priority is pan, roll, and tilt. The new Mo-Sys gyro-stabilized head is the design on the far left-hand side. Again, when the camera is horizontal, the pan axis, the roll axis, and the tilt axis all operate as expected, providing 3 axes of stability. When the camera points vertically down, the pan axis operates as expected, as does the roll axis, as does the tilt axis, ensuring that even in this camera position, there are still 3 axes of stabilization operating.
Okay, there's a little bit our history about stabilization. So this one was the lambda, where we learned a hell of a lot, that you shouldn't stabilize a non-symmetrical head. Yeah, we spent a long time on trying to get that off the ground, but we learned a lot. Here again, I think that was David Fincher movie. Here you see again the G50 head. We don't make it anymore. We actually got out of the gyro-stabilization at the point where they sort of started to come with very, very low cost systems and solutions. And that was our G50. But then we actually decided to now go back into stabilization because I saw there's a niche in the market. You have those small systems that are not suitable in a way for day-to-day filming process. And you have high-end, super expensive, very good stabilized system. And I thought you need something that is actually also suitable for virtual production, so built-in encoders and stuff. And here you actually see, we're going to launch it in a few weeks, and it works really well. It has actually a 45-degree frame rather than a 90-degree frame, like let's say the flight head, and it allows you to have more access to the camera, and the whole package gets shorter. Okay, here again, it's our new head. You have super large and strong motors, a massive hole through the middle. We have a hole through all three motors, including the pan, and that makes it easy to use. It's easy to operate as well, and it has those 45-degree frame, making the stabilized head actually much shorter than it would be with a 90-degree that goes all to the back. But yet you have the advantage of when you look down, you can have full motion and it fully stabilized also when you look down like it should do. Okay, now I would like to hand over to Kenneth. Kenneth couldn't be with us today, so we actually shot a little video.
So yeah, hello, my name's Kenneth Mckenzie. I'm a key grip. I work in Montreal in Canada. I'm originally from England, but I've never worked there. This year, actually, for the first time, got to visit an English movie set. I went there on holiday to visit Mo-Sys, and while I was there, I went to visit the set of Venom 2 or 3, whichever one they last shot. And I went to see my old DP that I've worked with many times, Larry Blamford, and Jim Churchman, who's the stunt coordinator on that, and Brian Smers, who was directing it. So for me, it was fun to go and see an English set and what happens in England. I'm astonished at how busy they are. And I was intrigued to talk to, well, the key grip that I talked to, he's really after a new remote head. Not a new one, a first one. He wants to buy one. He just feels like it's something that could be interesting. And I felt that Mo-Sys is uniquely positioned to supply something that would be appropriate for what they want. I've known Mo-Sys for, I can't remember how long, years and years and years, at least 12, 15, maybe more years. It was Anna Forrester who originally mentioned a company in England that built a motorized lambda head. And I think it took me 3 years to figure out who that company was. And then I eventually figured it out, and I went to see them, and I bought a lambda head. And it was a real motorized lambda head. It wasn't one with bolt-on gears or things that I felt just weren't really quite up to what I wanted to do. And the gears in it were incredibly strong. The head was a little bit heavy, and they've since come up with something called the L40, which replaces that original lambda. And it's lighter and it's easier to work with. There's no lag, there's no delay. Operators are often have a difficult time trying to keep up with very fast action because the head has a delay in it. And by the time they've reacted, that delay means they missed the shot. But with an L40 or a Mo-Sys Lambda, you just don't have that delay. It's instant. I've even had one operator who used to stop looking at his monitor and would stick his head out of the tent and watch the action live because the video feed had a delay. The head didn't, but the video feed did. And if he's watching a delayed video feed, he misses the action. This particular shot was a guy jumping on a trampoline and he couldn't follow him. But as soon as he stuck his head out the window and watched the guy jumping, he could follow him easily. Usually when you change lenses, the head tech has to rush over and hold the unbalanced rig to stop everything basically collapsing. I mean, the tilt motor just lets go and everything has to be supported while you change a lens. So that means just, you know, the tech has to be aware of what's going on and pay attention. Whereas with the L40, you can change a lens without anybody being there. Just pull the lens off and stick a new one on. You can even pull a big zoom off without really supporting it. The motors can just hold it. So it makes it easier as a techless head not to have to worry about that sort of thing. I think probably one of the main differences between the Lambda head and the L40 is slip rings. Slip rings are a nightmare. Anybody who deals with remote heads knows that slip rings are just asking for trouble. And the new L40 has solved that issue because there's a giant hole in the pan motor. So you just run your cables through the hole. I found that over the years, stabilization has become sort of a must-have. So many people want it, even when they don't really need it. You're on a techno crane, they want stabilization. But most of the time, we can do non-stabilized on the techno crane. But I'm really excited because Mo-Sys is now in the process of developing a new little stabilized head. I feel like I've had a bit of influence in getting them to do this, and they've taken something that they were already working on and now agreed that they're going to pursue this small stabilized remote head, again with a hole in the middle and a new geometry, which I've only ever seen done once by a company in Canada for helicopter heads. The fact that the Mo-Sys L40 is wireless, in fact, I think I probably got the first wireless. I was constantly prodding Mo-Sys to get the wireless working because I found so many instances where it would work. I recently did 2 hockey movies in Montreal. The first one was Pee-wee, and then they did a subsequent one called Junior Major, which was just a continuation of the original Pee-wee. And all of the work we did on the ice was done using a wireless L40. And we never had an issue. I was very concerned that hockey arenas would be a terrible place for wireless to work in. The ice is highly reflective. The glass all around the arena is highly reflective. And we never had an issue with wireless dropout. I was really impressed. And we built a very lightweight skate dolly that we put the head on with a bazooka riser. And now 1 or 2 people could really push that dolly really quickly and keep up with the hockey players. I was able to keep up with the 13-year-old kids quite easily. When they turned 18, not so much. That became a different type of shoot. Yeah, great little heads. Highly recommend it.
Okay, thank you very much, Kenneth, for recording that for us. And I would like to now hand over to Gary and Bob in Atlanta at Procam.
Hi, I'm Gary Attanasio, Business Development for the Americas. I'm here at Procam Reynolds, Atlanta, where we have Joe Allegro, who's the General Manager of Procam Atlanta, and Bob Gorlick, Camera Operator Extraordinaire. And we also have Andy here, who's our tech. And we're going to show you a couple of things. One is we're going to show you a demonstration of the back pan option that is on our L40 head. We're also going to show you how easy it is to set up an L40 from out of the Pelican box to well, I'll show you that later. Joe, would you like to say a couple of words about that?
Why don't we get to the demo and then I'll follow it up with that.
Sounds good.
Okay. Okay.
So we're going to now demonstrate the back pan option on the L40 head.
Okay.
Hi, everyone. Just before we get into it, I just want to say a few things. I like to thank the SOC for putting out this online webinar. I'd like to thank Mo-Sys for sponsoring and participating in Procam, and also to Tom Jordan and Full Frame Camera Rental for providing the camera and lens that's on the crane. I think I'm going to talk a little bit about the remote head from a camera operator's perspective. I do own one. This is my head, this L40. And I just want to talk about how I use it and why I use it, and some of those things before we actually get into showing you how to set up the head and the console. You know, I found originally I bought the head because I was, you know, doing jobs with a lot of stunts and camera, you know, the camera going into some dangerous camera positions. But I found that, you know, once I started using it, I found more and more reasons to pull it out of the truck and use it. I've gotten to the point where I'm using it on the dolly almost 50% of the time, and I find that, for one, I can be positioned or situated comfortably closer to a director, closer to a DP. So, you know, that eliminates some of the communication vacuum that can happen often when you're, you know, on a set and Video Village is far away, or the DIT village is far away. I can also, you know, hear what the director and the other people in Video Village are talking about, so that I can address whatever it is that they're looking for in a much more efficient way. And as Mitch mentioned earlier, with COVID and, you know, the new shooting considerations that we'll have, I definitely think that having a remote head and the ability to keep the set, you know, freer of people being on set is actually it's going to be a very good thing. Being able to operate remotely does bring up a couple of other issues, such as communication with your dolly grip. So I do like to use headsets, either HMEs. HMEs are a popular brand of headset, also EarTech. So I can communicate with the dolly grip, the DP, whoever's working on, if the head is mounted on a crane, you know, we can communicate with the person operating the crane as well. Okay, so why don't we get into setting the head up? We'll bring in Andy and Joe, and we have another L40 here, which we can pull out of the cases and show how easy this thing is to set up. So this is Andy. He's our tech today. He's going to help show us how to set this thing up. We also want to demonstrate how the head can be used. It doesn't have to be used on a crane. It can also be used on a tripod or a dolly. Any Mitchell-based mount would work with this head. It's very simple.
Except when we get to the castle. The hardest part of the whole
Yeah, the castle nut's the hardest part.
There we go.
Now the console. Once we get this set up, we're not going to actually put a camera on this particular head. Once Andy gets everything cable, we'll show you how simple that is to do. We'll go over to the jib arm and show you the backhand compensation and how that works. Also, the head can be powered from a camera battery, 12 to 32 volt camera battery, or an AC power supply, which we're using here. No echo, fantastic. So basically, there are two things to plug in, actually three. There's the Power XLR, then a short bus from the console to the hand wheels, There's only one way to plug this in. It cannot be plugged in wrong.
I can't find the keyboard.
Okay, and don't forget
There's a terminator.
the terminator. There's one that goes here and one that goes on the head that's got the camera on it. These hand wheels are made of solid bronze, I'm sorry. And they are really beautiful, smooth, perfectly balanced, just a joy to work with. Very solid feel. Then you just link one hand wheel to the other. And now the bus. What you want to do here is don't power it yet. You want to wait until all the cables are connected. And here you can see what Michael was talking about so much with the hole to pass the cable through. As it comes up. There you go. Keeping your cables nice and tidy. And another terminator on this end. And that's it. You're all set.
Powered up.
You want to power the console first. The sequence that works. Wait for the green light to come on. And voila. Let's see if you can see that. Pan and tilt. That's great.
There you go.
All right. Now we'll go over to the camera that's set up here. We put some tape here on the head so that you can clearly see the back pan at work, and Joe Allegro is operating for us. So imagine, you know, if one thing we want to mention is that this is not a it's not a target kind of compensation. So you can't line up on something and it will it's not a tracking type of compensation. It's more of a correctional compensation. So as the crane moves left and right in arcs, you can see by the tape that the head, Joe is not really doing anything on the wheels. He's only feathering it in, but the head is maintaining its orientation towards the subject on its own. So basically the back pan compensation, which side? Yes. Okay. Let's see if you can see it better. It's hard to tell from this angle, seriously. Yeah, I think it, maybe from the front. Try it again. You can see how the mat box maintains its orientation towards my phone, which is filming this, as the arm moves. And the operator really isn't doing anything. Head's moving on its own. The operator, you know, you basically, Joe is feathering it. They move the arm again. Arm left. And you can see that the camera maintains its position towards the subject. The console itself, very simple. Why did we lose picture? There's a battery problem here. The console is very, very simple. There are two types of consoles. This is the push button console. There's also a more sophisticated touch screen. which many people who have owned the Lambda Mo-Sys have seen before. I like this one. It just, it doesn't have any repeatable memory for moves, but it just keeps your panning and tilting options very, very simple. Power buttons in the back. This is enable, disable, back pan button. You have sensitivity of the back pan. You have directional control. Where's that? That is right there. And smoothing, which is kind of like feathering of your pan. And then of course you can set soft stops for your pan or tilt.
Touchscreen console.
This is the touch screen console. And there it is.
Did you want to show anything on this here on the desktop?
All right, I'm going to pass you over to Joe Allegro, who's going to say a few things.
Do you want me to? Okay.
Yeah.
Hi guys, my name is Joe Allegro. I'm the general manager here at ProCam Atlanta. Mo-Sys has asked me to say a couple of things about the L40. We are a telescopic / remote head camera rental house. I house several remote heads here, stabilized and non-stabilized heads. The L40 is definitely one of our most popular rental heads, specifically for the simplicity of it, no tech. It's just out of the box, it's camera ready real quick. And you know, all in all, out of all the heads that I have here, it's probably one of the most popular heads. With the way that the times are right now, remote heads being very popular, they're going out a lot, and you know what, we're very happy to have Mo-Sys here in our inventory.
All right, so we have a couple questions. I'm just gonna call them out, and Marcus, if you wanna jump in, just let me know, but we've got one here from Jeff Haley. If you wanna go ahead and unmute yourself, Jeff, and ask the question.
Hey guys, I was just curious what the timetable was on the stabilized version of that. When's that gonna be available?
We built the first one. It's ready in Australia on horse races, and we're getting really, really good response back. And that enabled us to basically build the first batch of the first 10 are going to be built, and they're going to be available 5-6 weeks.
And they will need to be teched, or do you think they would also be simple enough to be techless?
Now, there's one thing I was thinking I should have probably mentioned earlier. The whole thing about stabilization, it would be a dream to have a tactless stabilization. There's quite a lot of things one needs to understand about stabilization. And that's why, for example, the Liberates from ProCam, they go all out with text. That sometimes there's stuff on a shoot you don't even see what they do or what they need to do. I mean, just as an example, if you do a movement of the structure, let's say of the crane, and the head compensates against it, if there would be a slight delay, and there's always a little bit, if you, for example, have the head not mounted firmly, or it's on some sort of elastic structure, there's a little bit of give or something loose, the whole thing will start shaking. And then everybody says, whoa, there's something wrong with the head. No, it's not. It's just like at the moment there's something loose, the head will use that space and sort of move around. The same thing if you have, for example, let's say a monitor a little bit on just a clamp on the head. The head will want to shake that thing because it's an energy of the monitor to move, and that against. So I don't think a gyro-stabilized head should be techless. Or no, hang on. I mean, not techless, but it should be somebody experienced and understands about gyro-stabilization. So we did try to make our as simple as possible. And the first version, for instance, because of Corona, we sent it to the owners, and they set it up themselves, and they're operating it. So you could call that techless. But it needs somebody with a willingness to understand the technology or the physics behind it. It's the physics primarily.
Got it. So an operator
Have I answered that?
Yeah. So you're saying that an operator that buys it, who gets familiar with it enough to understand sort of the physical principles and the physics behind the stabilization portion of it, could potentially be solid enough on it to essentially tech it themselves.
Yeah.
Okay.
So from its complexity, it's similar to, let's say, DJI or Movi, but from its frame and strength and capacity, it is just a step up.
Great. Thank you very much.
Thank you, Jeff. Mitch, you had a question.
Yeah, hi. Actually, I have a couple questions in reference to Jeff's question about teching a stabilized head. I would suggest to you at Mo-Sys that when you introduce this new stabilized head, that you offer training to people that are going to be purchasing it, and that all these heads that are, stabilized heads that are going out as techless, it only reflects well on the piece of equipment if the people that are using it are experts at it. So it's, I think, really important to offer training with these things.
Exactly.
That's one point. The other question I have is they at ProCam in Atlanta, they didn't really get into balancing the head, and I know how important that is on remote heads, especially stabilized heads. I don't know, is that a big issue there with the L40, and is it complicated to balance that head?
No, I mean, you would balance it. The gears of the L40 are quite strong, but they also have some sort of resistance. And you would put your camera package on and then shift it forwards and backwards until it's sort of okay. As Kenneth was mentioning earlier, it's really damn strong, that thing. And you can have, I don't know, a massive lens in front and take it off, and the thing will still hold it. So the strength is there to even use it when it's not balanced, but it's not good because you will consume much more power, you will drain the battery. Of course, something needs to hold that. The other thing, just in case you would have a power failure or somebody unplugs the battery, then of course the thing will fall down. There is quite a significant resistance in the gear, so it will not just bang fall down, but it will slowly go down. And I would recommend, it's better to balance the L40, but it's not necessary.
Yeah, I mean, it would perform better balance, but the question
Exactly.
is it a complicated process to balance the head? Are you balancing multiple axes, like on the Lambda? Of course, Jeff and I went through, but is it nodal balance or is it just a front and back balance?
Hey, Mitch. So yeah, I mean, balancing the L40, unlike a lever head that it's got a lot more free balance when the motors are off and everything, it's quite simple balancing the L40. You just have to kind of find out where the middle of the camera is with the lens on it. Because of so much resistance on it, it's hard to just let it fall. So if you find out where your center point is on there, that's pretty much where the balance is going to be. And like I said, or he was saying, if you turn the motors off or something, it's not going to fall out if it's just a little bit out of balance.
But I'm sorry, I keep saying this, and I don't want to take too much time, but it's just a fore-aft balance, or is there an up-down center of gravity balance?
So forward-aft is our first balance. Side-to-side, we do have side-to-side balance on it too. Top to bottom, we do have that also, but I would go in that sequence from front to back, side to side, top to bottom. And front to back being the most critical balance.
Yeah, and that's something that is not complicated to do, that we don't need a text.
Not at all. Not at all. Very simple to do.
Thank you.
All right, gentlemen, we have a question from Buzz. Buzz Moore, you want to go and mute yourself?
Hey, hi guys. Thanks for doing this. Can you hear me? not coming up with nothing.
Yeah.
Yeah, thanks for doing this. It was very informative, and I certainly look forward to the stabilized version of the head. I was wondering if someone were to purchase one of the current heads in the United States, what are the options for service and updates? We all own equipment, not all of us, but all of us own equipment, and having a reliable service and at least available here would be important. So what are the options for that in the United States?
In the first place is to design equipment in a way that it doesn't break down. And the second place, I mean, we have now technicians in LA, at Gary is in Atlanta. We also have somebody in New York.
Fantastic. Thanks very much. Thank you. Thanks.
All right, we have a question here from Chris. You want to go ahead and unmute yourself?
Hi guys, I was just curious with the new head, will there be a bus cabled system and a wireless option as well, like the L40?
There's yes, it's wireless and with a cable. I only wanted to mention that it was meant to be about the L40. I even haven't given away his name, but yeah. Yes, of course, wireless as well as cable.
So Michael, if people have questions about that, should I send them to the info@mo-sys.com email?
Yeah.
Okay.
I would love to. Yeah.
Okay, in
Could
case
do
there's
that.
any questions about the soon-to-be secret product. I will put it in the chat and everybody can send emails, and Marcus and Michael and the team can answer those if you have them. So I just realized too, Michael and Marcus, when you are getting ready to announce any product information or anything that you'd like the membership to be aware of, we can easily post that in the membership portal under the membership benefits area. So if you're an SOC member, you can log on and take a look at what we have posted there, if that's something you're be willing to do, gentlemen.
Oh, thank you very much for that offer. Yeah, we will take you up on that.
Wonderful, great. Is there anything anybody'd like to say in closing? I think we've wrapped up all the questions, unless anybody.
I think Jeff Malstock has a question. It says.
Thank you, Jeff. I can't keep up with the chat.
I just want to say thank you. First of all, I'm a huge fan of the L40. I kept it full time on the last Netflix show I did called Hit and Run, which will come out next year. But in any event, my biggest concern with the unit has always been the wireless. And forgive me if I missed it. I know you talked briefly about it, but is this a newer wireless system that's going to incorporate into the L40?
How old is your wireless system? Because it did have some changes there.
Right. We come through Monster Remotes out here on the East Coast in New York. So I couldn't answer that specifically, but I assume it's a year old.
I mean, when designing the wireless, we really tried to have as little delay as possible. And I don't think you'd. But on the new head, the wireless is different. It's a different wireless.
Okay, good to know. But yeah, that's always been my hesitation in going wireless. There's always been sort of some issues we've had in the past. So I'll find out if it's what age that system is moving forward. But I love the head. Huge fan.
Would it be possible to contact you? I would like to know those issues.
Yeah, sure, of course.
And then, I mean, we can only fix things if we know about them.
Absolutely.
Cool. I will connect the two of you via email.
Fantastic. Thanks,
Great.
Jeff.
Thank you, Kristen. Sure.
I think that's it for the questions. Anything that anybody would like to say in parting, wrapping up our session today?
I would just say thank you, Mo-Sys, for taking the time and presenting your remote heads to us, and we look forward to the new model. Thank you for giving us a sneak peek. And yeah, I just want to stress again that remote heads are really important now in a COVID environment. So thank you. for taking the time today and sharing with us.
Thank you, Mitch. Thank you, Christine. And thank you, everybody in Atlanta. And thank you, everybody else, for joining us.
Thank you all, Atlanta, London, and LA. Everybody be safe, practice safe practices on set and in your communities. And we'll see you soon at the SOC.